A very warm welcome to everybody. Myself Vedan Kai and our team name is Team API Alchemist. So our SIH problem statement is SIH 25041. So that is an AI-driven uniform data platform for oceanographic, fisheries and molecular biodiversity insights. Under this vital theme of renewable energy and sustainable energy, we recognize that our health of oceans is instinctively linked to the sustainable of our planet. However, our ability to protect these crucial ecosystems is hampered by functional different problems that are inaccessible and complex data. Our project aims to exactly solve this problem. We are building a software platform for this so the stakeholders can use them. So how we propose the solution for this? So our oceans are telling a story of vast amount of data from traditional fishery logs to groundbreaking environment DNAs. In that, the problem is that the data is different in formats and also from different places, so that this makes incredibly difficult to get a clear holistic picture of marine ecosystems. Our proposed solution is that a single unified platform breaks down the silos. We will automate the collection of our standardization data, diverse of marine data, ensuring everything clean, consistent, ready for analysis. In that, at the heart of our platform lies between AI and machine learning algorithms, which we will use to uncover critical links between ocean conditions and biodiversity, turning raw data actionable intelligence. And with a modular architecture built on our APIs, we ensure our platform is closed box, but a collaborative tool that can grow to and integrate other researchers in the system of future scope. So how does we solve and tackle the problem? So bringing a single unified system, we solve that this enables a faster evidence-based decisions for crucial areas like fishery management, where eDNA sequencing, taxonomy, otoliths, and mapping of oceanography is done in our project. So furthermore, we are making powerful data accessible to everyone, where adding an AI-powered chatbot allows non-technical users like policymakers to ask plain language, get intimidate questions so that they can get answer in fair module. So this was for our idea proposed solution. Now the next part is
thinking as an analogy for data architecture as a master chef. First, bronze layer is considered as pantry, where all raw ingredients are stored that we collected in original and untouched state. Nothing is thrown away or altered. This is permanent record of all data you have received. Second is silver layer, considered as kitchen. You start preparing ingredients, so you clean, sort, and organize so they all look same. This discards duplicate and dirty data. Third, global layer, plated dish, final step where perfect dish is created, ready to use ingredients for AI models. We combine and prepare data in best way for training and using our AI, making sure it's fast and easy to work.
so. So our next part is multi-model AI engine. So it consists of algorithms and rationally. So every car has its engine and parts having with all attributes. So does our have. So our AI engine of multi-model is working with automated species ID, forecasting ecosystems and casual driver analysis. So in automated species IDs there is efficient net v2, deep learning and transfer learning with data augmentation. So what does this efficient net v2 do? So it is the next advanced model of efficient net v1 where image processing is done in the faster way. So various gradients and the attributes of larger size and image quality with its color mapping is done in efficient net v2. So next is transfer learning. So what does this transfer learning do is that we can provide different data sets to a single model, so by which it can train itself on the data sets and give its respected output. But the transfer learning algorithms only refers to the similar attributes. In the another part is casual driver analysis, where XGBoost and SHAP analysis is done. So what is XGBoost is that is extend grading boosting. So whenever logical errors are happening in our data models, which are AI data predictive models, where decision trees are formed, then multiple decision trees are combined together and predictions are made correct and errors are reduced. That's why XGBoost is done. That is next is SHAP analysis, that is shapely analysis. Whenever we are providing an we can say an attribute, does it making that AI model specified with its features with that attribute that is identified by its SHAP analysis, that is shape analysis. How much amount or measures that it is happening and providing a proper solution or having a weightage to that particular attribute is can be given by that SHAP analysis for a specific attribute. That's why the another part is can be explained by Heram.
How can we predict the future health of our marine ecosystems? At Samudra Setu, we are moving from analysis to foresight. To do this, we use NBITS, a powerful deep learning model that learns complex seasonal patterns and long-term trends directly from its historical data. But to ensure we can trust these predictions, we perform rigorous backtesting. By testing our model on the past data, we validate its accuracy against known outcomes. This gives us reliable, data-driven forecasts to help protect our oceans for tomorrow.
So here's the breakdown of the core technology stack and why each tool is being used. So for the front end, we have used React and leaflet.js, which is used for creating interactive maps, and .3.js, d3.js, which will be used for custom data-driven visualizations, and Tailwind, which is the CSS framework. And for the backend, which is the server-side logic that powers the platform, for that we are going to use Python fast API. From that we will create custom APIs, and for WebSockets, which is a two-way communication channel between the users, browser, and the server. And for the databases, we have used PostgreSQL, which is the relational database, and the Neo4j, which is a graph database, which will manage complex interconnected data like taxonomic hierarchies and species relationships. And S3, which is a simple storage device, which will manage the unstructured data such as large molecular biology files or the images of the otoliths. And for AI/ML, we are going to use PyTorch, XGBoost, which is a extreme gradient boosting, which will be used for predicting species distribution based on the oceanographic parameters, and machine learning flow, which will be managing the entire machine learning lifecycle. And for the data pipeline, which shows how the data moves into the system and how it is processed, for which we are going to use Kafka Debezium, which is a data distributed streaming platform, and DBT, which is a tool that allows for transforming and modeling the data in the data warehouse using simple SQL. And for the deployment, we are going to use Docker, which will be used for standardized unit called container, and Kubernetes and Terraform.
Hello everyone, my name is Kunal Ganesh Patil and I will be taking you to our hackathon execution plan. We have broken our workflow into three structure phases. First phase is foundation and data flow. In this phase, we will set up the live containerized data backbone, the very heart of the Samudra Setu. Our goal here is to create an API that serves unified quality tested data on an interactive map, allowing real-time visualization of marine data. In second phase, once the foundation is ready, we move to building core intelligence. Here we will develop and deploy a predictive model, especially an XBoost model with sharp explanation, making our AI decisions transparent and interpretable. This will accessible via a dedicated Insight API endpoint. Now phase 3. Finally, in the integration and polish phase, we will bring everything together into a seamless user-friendly interface. A polished UI will integrate all insights and we will deploy it live using a free platform as a service for easy judging and scalability. So as we can see, Samudra Setu is both technically sound and execution ready from concept to deployment. Now, Hiram will take you through feasibility of our project.
Is our idea just a concept or can we actually build it? That's the core question of feasibility. I am here to show you that our project is built on the rock solid technical foundation. Let's break down why. First, data handling. We are dealing with the massive oceanographic fisheries and biodiversity data sets. This isn't a problem. We will leverage the existing and powerful cloud and big data technologies that are specifically designed to handle this scale of information efficiently and securely. Second, our AI and machine learning models, we are starting from the scratch here. We are implementing the proven AI and ML models like predictive analytics and anomaly detection that have already been successfully applied in related fields. This means our core engine is reliable, powerful, and ready to generate insights from day one. Third, we have designed a modular architecture. Think of it, it's like building with the Legos. Our API driven system is flexible and scalable. This makes it easy to integrate new datasets and connect with the external research platforms, ensuring our project can grow and adapt well into the future. And finally, our use of open source tools. We are building on the shoulders of giants by using powerful community vetted tools like TensorFlow, PyTorch, and Docker. This strategy is smart. It keeps our costs low, gives us incredible power, and ensures our solution is both robust and scalable. Thank you so much. Next part will be explained by Kunal.
Now, take a closer look at the challenges. However, creating a unified data platform comes with its own set of challenges. Through our analysis, we have identified key barriers to unified platform adoption. Issues like data standardization, diverse data sources, biased or missing data, and infrastructure constraints can slow adoption. Additionally, factors like stakeholders' resistance and slow adoption rates can pose barriers. But we have anticipated all of these and we have clear strategies to overcome them. Our solution roadmap includes developing automated ETL pipelines to clean, transform, and standardize data at scale, applying data validation and continuous model retraining to ensure accuracy, using cloud native deployment via Docker and Kubernetes for high scalability, building user-friendly APIs, dashboards, and integrating LLMs to make insight accessible to all. Finally, we will engage early with institutions and communities to ensure relevance, trust, and smooth adoption. So, in short, the technology is ready and approach is scalable, and our plan is strategically sounds better. Now, the further parts will be explained by our other teammates.
Social benefits promote sustainable fishing. Platform integrates data from sources and AI algorithm analyzes this information to create predictive models that can forecast migration patterns of the fishes. So this reduces the fishermen to know where fishes are and when to fish without exploiting specific areas. Second, enhances public knowledge and awareness. Platform translate complex scientific data into accessible dashboards and visualizations. By making information available to public, it can spark interest in marine conservation. Strengthens collaboration. Platform act as a central hub where scientific institutions, local stakeholders can share and access single source of truth. Environmental benefits. This protects marine ecosystem via early detection of biodiversity loss. Our platform uses machine learning to analyze environmental eDNA samples. It can automatically identify species and detect anomalies, so sudden drop in fish population can be much faster than a human could. Helps track climate change impact on ocean. The platform ingests real-time data from APIs to monitor ocean temperature. AI model then can use this data to predict climate-related shifts. Encourages sustainable exploitation of marine sources. Governments are just guessing or relating to problems after they happen, like fish population in danger. Our platform gives them smarter decisions. This allows to design policies that protect environment. Third, economic benefits. Our solution provides strong economic benefits. It helps optimize fisheries management, reducing overfishing and minimizing economic losses. It also supports growth of marine-based industries like aquaculture, ecotourism, and sustainable seafood markets. Finally, it opens opportunity for startups and innovators to monetize AI-driven marine application, promoting technological and economic development.
So for the research and references, we are going to use WOD 23 user manual, which is the World Ocean Database manual, in which we have researched and studied about the different types of oceans and their parameters. And the links of the datasets are present in the slides, as you can see. And we are going to use Google Colab for our initial training model. And also we are going to develop documentation for our open source API, which will be used by everyone and they can implement in their projects. So the overall conclusion of our project is that it is an online platform which will bring all the marine data which is being scattered, hard to use, and the information about the ocean and the tiny sea life into one central place. So it is overall a powerful tool for our Indian scientists, which they can see how scientists things like ocean temperature affect the fish population, and also it will make their research faster and help our country to make smarter decisions about fishing and protecting its oceans, supporting a thriving blue economy. So thank you for watching our video.
Hello everyone, welcome to Samudra Setu project demonstration. In this video, I will be walking you through the user interface and front-end features of our platform. While our project also includes powerful AI models that analyze various ocean and biodiversity data, my teammates will explain those models in detail. Here, I will focus on how the platform presents insights in a user-friendly and interactive way. The main goal of this project is to create a bridge between technology and marine education. That's why we named it Samudra Setu, meaning bridge to the ocean. We start with the home section, which gives a quick overview of our platform and its capabilities. Samudra Setu is designed to integrate multiple ocean data sources, providing comprehensive insights into fisheries, biodiversity, and climate impacts. Next is the features section. Here, users can explore the main functionalities of our platform. These features are powered by 4 AI models implemented by our team. First one is which detects the species name from the fish images. Second, it identifies the species from otolith images. Third one is it predicts species accurately from the DNA sequences. And for oceanographic data, the AI provides predictive insights. Again, the detailed explanation of these AI models is covered by my teammates in their sections. The next part is visualization, which is one of the highlights of the Samudra Setu project, which represent data in multiple formats for better understanding. First one, the biodiversity section, in which the bar graphs showing species distribution and diversity trends. Second one is fisheries, in which lines graphs tracking population trends and the migration patterns over the time. Third one is oceanography, in which the spider charts displaying multiple ocean parameters like temperature, salinity, and currents simultaneously. The fourth one is climate impact, in which pie charts summarizing environmental and climate effects. These visualizations are interactive and allowing users to explore, filter, and analyze the data in real time. Moving on the dashboard. This is where user can see real-time monitoring of ocean parameters and AI-driven insights. Finally, the About section provides information about our team and objectives of the Samudra Setu. This completes the UI walkthrough of our project. To summarize, Samudra Setu combines advanced AI capabilities with a clean interactive interface, making complex ocean and biodiversity data accessible and actionable for researchers and decision makers alike. Thank you for watching this demo. Hello everyone, in this part of our project demonstration, I will be showing the working of our chatbot feature, which is an additional functionality we have implemented in our project Samudra Setu. This chatbot is designed to answer user queries related to marine life. It provides text-based responses to questions such as details about different fish species, their habitat, and physical characteristics and migration patterns. As you can see on the screen, the user types a question like, "Tell me about the American eel," and the chatbot instantly responds with the detailed information about that species. Similarly, user can ask about other marine organisms and what will provide relevant facts from the data stored in our system. The main purpose of adding this chatbot is to make our platform more interactive and informative for users who want to quick access to marine life details without searching manually. Even though this feature was not included in expected deliverables of our problem statement, we decided to add it to enhance the user experience and demonstrate the potential of integrating AI-based communication in our project. So, this was the demonstration of our chatbot, a smart and interactive addition to our Samudra Setu project. Thank you.
This is Samudra Setu, our AI-driven oceanographic platform. Our key feature is the AI fish identifier. It instantly analyzes an image to determine the species. We achieve this using the transfer learning with the powerful efficient net version 2 model enhanced by the data augmentation to ensure its accuracy and rapid identification.
So, hello everybody, myself Vedan Kai, and I am the one of the teammate of Team API Alchemist. So, this is one of the modules that of Samudra Setu. So, the engine empowering our Samudra Setu application is a custom-built API that does much more than just serve data. I would like to take a moment to explain how it works. So, as its foundation, this is a REST API built from Python and Flask framework. Its primary job is to act as an intelligent bridge to our dataset. When you type query into search box, the front-end sends a request to this API, then the API performs multi-field search across our data. After that, allowing users to find a specified by its eDNA. But the real power of our API is in its ability to enrich the data in real time. Once a match is found, the API doesn't just send back the stored information, but it takes the scientific name, makes two additional calls to the web. First, it queries the Wikipedia API to pull a concise summary of species. Then second is Google Custom Search API to find a written and relevant image. Then after, this process transforms a simple data lookup into rich, dynamic, and educational experience for the user. Finally, we are going to demonstrate some of our then how it works. So currently I am having a fish name, which is a scientific fish. So let's search through our API. So as you can see, its eDNA is represented in here. The fish name is here. Then the scientific name and about this, how its origin is from, and about its relevant information is given it. So that's for this API. And also we are going to provide how we can other users can install our user APIs. So researchers and scientific research communities can get this together. Thank you.
So this is our otolith LLM model. In this, we have used a convolutional neural network, CNN. We trained it on thousands of images, teaching it to recognize subtle defining patterns in the otolith structure. This is a special multi-output model. Unlike a simple classifier, it doesn't just give one answer. It predicts the entire taxonomic breakdown simultaneously. So let's see how fast it works. Suppose a researcher uploads a new image of the otolith. And instantly the result appears, in which we can see the scientific name, family, genus, and the specific epithet of our otolith image. And it also gives the accuracy and the confidence of our predicted species.